In this video we'll take you on a journey. A journey of failure and woe, but with a positive ending. We've spent the last 3 days trying to make hydroxylamine, so we'll show you how we got on. Here's our 2 basic starting ingredients in the proportions for our first reaction. First of all, sodium nitrite. We're starting with 30 grams of the slightly pale yellow crystals. It's used in meat curing and as a preservative, so you can buy it from specialist suppliers online fairly easily. And now here's 90 grams of sodium bisulfite. Again, this is used as a preservative and in home brewing, so it's quite readily obtainable. The theory is that the bisulfite can act as a reducing agent and convert the nitrite to a hydroxylamine salt. Let's give it a go. First we've got to dissolve the bisulfite in the minimum quantity of cold water to make a saturated solution. So first we add a magnetic stir bar. And now we've measured about 80 ml of cold water to start with. We'll probably need a bit more. Let's get this into the beaker with the bisulfite. And we'll get this stirring to start to dissolve the solid. We slowly added more water until we had a saturated cold solution. Nearly there. Okay, about 180 ml total volume. We chilled this down so it's nice and cool. Our reaction vessel is going to be this 600 ml beaker. We'll put a large stir bar in here. First we add the solid 30 grams of sodium nitrite. And the instructions we're using tell us that we need 40 ml of water to start off with, so we measure and add this. It's very important to perform this reaction in the cold, below 0 degrees. So we set up an ice bath. And we added salt to this to get the temperature down even more. Okay, so now we're ready to set up. The beaker is in the ice bath and we've the thermometer in the reaction mixture so we can carefully monitor the temperature. Let's get stirring. The temperature drops in the beaker. In order to keep it down, we're also going to use some ice cubes in the mixture. Here's 100 grams of ice cubes. Let's get these in. And now our chilled bisulfite solution. Temperature of the mixture is at -10 degrees. So we'll add the first small portion of bisulfite. We added the bisulfite solution in portions with stirring, and not allowing the reaction mixture temperature to rise above 0 degrees C. Temperature still at -2 degrees C, so this is looking good. Towards the end we added a couple more ice cubes to keep the mixture below 0. Here we go. Complete addition took about 30 minutes, and at the end we've still got some ice floating around in here. There's not really any sign of the reaction taking place at all. We let the mixture stir for another 20 minutes, and then removed it from the ice bath. In theory, this mixture now contains our sodium hydroxylamine disulfate salt. This is pretty soluble, so it's not going to crystallize out on its own. Well, we've got a few options now. We could try to convert to the potassium salt, which apparently can crystallize out of solution. But this solution of the sodium salt can apparently also react with ketones to form oximes directly. So we figured we'd try this out. The best ketone to use would be methyl ethyl ketone, as the oxime apparently forms an insoluble layer. But we've only got acetone, so we'll try this. First we get the mixture stirring, And now here's 30 ml of acetone, which in theory should be enough to turn the 100% yield of the hydroxylamine disulfonate into the oxim. So we add this to the mixture. And now we're going to heat to 70 degrees C in order to allow the conversion to take place. Then we allow the mixture to cool slowly, and leave overnight at room temperature. Here we go. Apparently the best way to separate the oxim is by steam distilling it, so we're going to try to do this just by distilling the mixture directly and seeing if it can come over with the water. So here's a big flask and the mixture. We also added some broken glass to stop bumping. So let's distill the mixture and see what we get. On heating, we first get some acetone boiling off at a low temperature. Interestingly, although acetone doesn't form an azeotrope with water, we've got a vapor temperature starting at about 60 degrees and steadily rising to 100. Pretty quickly the temperature rises to 100 degrees. We've collected just over 20 ml of distillate, which is a mixture of acetone and water. So we keep going and distill off the rest of the liquid from the mixture. This boils at 100 degrees all the way to the end. At the end we've got a liquefied inorganic salt mixture in the flask, and distillation slows right down until hardly anything more is coming over. Right at the end we get some brown nitrogen dioxide fumes forming in the apparatus. We stop the distillation here. We've got about 300 ml of distillate. We first wanted to see if we could extract anything out of this using an organic solvent. So we put the mixture into a separating funnel, and then tried extracting with 30 ml of dichloromethane. After a whole minute of shaking we allow it to separate and then drain off the DCM bottom layer. We then dried the DCM using magnesium sulfate and then evaporated off the solvent on a hot water bath. And after all that, the result? Zero. Nothing. The flask was basically empty at the end. Well, it's possible that acetone oxim wants to dissolve in the water more than the DCM, but it seems unlikely we'd get nothing. We can't think of any other way to get it out though, and to hydrolyze 2-hydroxylamine in such as large amount of water is going to be very difficult. So we saved this distillate and started over with the reaction, following exactly the same process and creating the new reaction mixture from the sodium nitrite and bisulfite reaction at below 0 degrees. Here it is. This time we're going to try converting the sodium hydroxylamine intermediate into the potassium salt. So here we've weighed out 45 grams of potassium hydroxide. In theory the potassium ions should allow the potassium salt to crystallize out of the solution. We dissolved the potassium hydroxide in 50 grams of ice. And then chilled the solution. Okay, let's add this to our cool reaction mixture. And now we covered this up and chilled it down for 24 hours. This is supposedly the time required for crystallization to occur. Here's the result. Absolutely no crystals. This means we must be doing something wrong in the reaction. So we had another go at the reaction only using the smaller scale, and this time using as little water as possible. So we mixed 28 grams of sodium bisulfite with 40 ml of water and stirred to form a slurry. Not all of the solid dissolved, but we left the mixture as it was. Then we prepared a beaker and a very cold ice bath, and added 10 grams of sodium nitrite and just 8 ml of water. And we started off with 2 ice cubes. Starting temperature at -10 degrees, and this time we added slowly dropwise. During the first half of the reaction the temperature was at around -5. We added a total of 3 more ice cubes to keep the temperature down. The large extra cold ice bath helped a lot. Towards the end the temperature rose to about -2. And after about 30 minutes we're done. We left the mixture sit for another 15 minutes whilst we prepared the potassium hydroxide solution. This time making up a solution using 15 grams of potassium hydroxide and a single ice cube. We chilled this down and then added to the chilled reaction mixture. It's now almost syrupy in texture with the amount of dissolved solids in. We left this overnight to chill in the fridge to see if it worked this time. Hooray! This time we've got a mass of crystals in the beaker. The texture is a bit like a gel. So let's filter. The solid takes a lot of drying on the pump. Here we go. Not totally dry but nearly there. This is 23 grams of white solid. We're guessing a totally dry weight of somewhere between 15 and 20 grams. So a 50 to 60% yield of potassium hydroxylamine disulfonate. We did a couple of experiments which we'll cover in a future video, but we can prove that this has a large amount of potassium hydroxylamine disulfonate in it because it is able to be oxidized to a very distinctive compound called Fremy salt. So this is finally looking up. Possibly an OTC intermediate to hydroxylamine. Let's finally go back to the mixture from our second large-scale reaction. We added potassium hydroxide and then left for a total of 48 hours. There's a small amount of crystal, but not very much in here. So if you want this reaction to work, we suggest small batches, use the absolute minimum of water and ice, and use very good temperature control. And going via this potassium salt rather than directly to an oxim is probably going to be easier as a potential route to hydroxylamine. We'll let you know if we find a way. Stay tuned.